Hello guys, welcome to the 7th part of the chapter 8, that is Introduction to Trigonometry. In this video I'm going to teach you the basic 3 trigonometric identities, their proof and their use in the last exercise of chapter 8, that is 8.4. So before going into the 3 trigonometric identities, let me define you what a trigonometric identity is. So basically an equation involving trigonometric ratios of an angle is called a trigonometric identity if it is true for all values of the angles involved. Just like in linear algebra, a plus b whole square is equal to a square plus twice ab plus b square. Now this is an identity because it is true for all the values of a and b. Similarly, an equation involving trigonometric ratios will be called a trigonometric identity if it is true for all the values of the angles involved in the equation. So basically we are going to use just 3 simple trigonometric identities in this chapter. They are sin square a plus cos square a equal to 1, 1 plus tan square a equal to sec square a, and cot square a plus 1 is equal to cosec square a. So these are the 3 identities which you need to learn in order to solve the last exercise. So before solving the last exercise, let me give you a simple proof of these 3 trigonometric identities. So in order to prove the identities, you need to draw a right angle triangle. Here I have drawn the right angle triangle at angle B, and I have taken the angle of reference to be A. That is, we are going to define all the trigonometric ratios in terms of angle A. First of all, I have written all the trigonometric ratios in terms of angle A. They are sin A, cos A, tan A, cosec of A, sec A, and cot A. I have written this using that sentence, that is, some people have curly black hair turns permanently brown. If you have any doubt in writing this trigonometric ratios, you can just go to the first video and just learn how to write these trigonometric ratios using that sentence. Now what we do next is apply Pythagoras theorem to this triangle, that is base square plus perpendicular square is equal to hypotenuse square. So here base is AB, perpendicular is BC, and the hypotenuse is AC. So AB square plus BC square becomes AC square, and the next step is we divide both the sides by AC square. So we get AB square by AC square plus BC square by AC square is equal to AC square by AC square. They get cancelled out, and we get AB by AC whole square plus BC by AC whole square equal to 1. Now we see that from here AB by AC comes out to be cos of A. So AB by AC whole square comes out to be cos square A. And BC by AC it is sin A, so BC by AC whole square, it comes out to be sin square A. So we get cos square A plus sin square A is equal to 1. Now for the second equation, what we do is divide this equation by AB square. Then we get AB square by AB square plus BC square by AB square is equal to AC square by AB square. And then on seeing the trigonometric ratio of these ratios, we find AB square by AB square, it comes out to be 1, and then BC by AB it is tan of A, so it comes out to be tan square A since it is squared here. And then AC by AB it is sec of A, so AC square by AB square comes out to be sec square A. And for the last equation, what we do is divide this equation by BC square. So what we get is AB square by BC square plus BC square by BC square is equal to AC square by BC square. So we get from here we see that AB by BC is cot of A. So AB square by BC square becomes cot square A, and AC by BC is cosec square A. So AC square by BC square becomes cosec square A, and then we get the third trigonometric identity, that is cot square A plus 1 is equal to cosec square A. So basically these are the 3 basic trigonometric identities which we are going to use in the last exercise to solve the various problems. So let's begin with the last exercise 8.4. So here the first problem is express the trigonometric ratios sin of A, sec of A, and tan of A in terms of cot of A. Here what we need to do is write all the trigonometric ratios, that is sin of A, sec of A, and tan of A in terms of only cot A, not using any other trigonometric ratios. So how we do that is, first of all, as we know, we can write x as root over x square. So in the same way we can write sine of a is equal to root over sine square a. Also we know that sine of a is equal to 1 by cosec a. So sine square a becomes 1 by cosec square a. And also from the trigonometric identities which I have described just now, we know that cot square a plus 1 is equal to cosec square a. So in place of cosec square a we can write just cot square a plus 1. Now there is a root over in both numerator and denominator. We write it, then it becomes root over 1 in the numerator and root over cot square a plus 1 in the denominator, and root over 1 comes out to be 1, and in the denominator it is again cot square a plus 1 under the root over sign. So this is it. Now the next is we write sec a in terms of cot a. How we do that is simply again we write sec a as root over sec square a, and from the trigonometric identities we know that 1 plus tan square a is equal to sec square a. So in place of sec square a we write 1 plus tan square a, and also we know that tan of a is equal to 1 by cot a. So tan square a becomes 1 by cot square a, and then we take the LCM as cot square a and write in the numerator cot square a plus 1, and we take the root over in both numerator and denominator. The root over and the square in the denominator get cancelled out, and it just gives cot a in the denominator. And for the third part, tan of a, we can just simply write tan of a is equal to 1 by cot of a. Now the second problem is to write all the trigonometric ratios of angle A in terms of sec of A. That is, we have to write the other trigonometric ratios. They are sine, cos, tan, cosec and cot in terms of only sec of A. So for sine of A, what we do is we write sine of A as root over sine square A like in the previous problem, and we know that sine square A plus cos square A is equal to 1. So in place of sine square A we can write 1 minus cos square A, and for cos square A we write it as 1 by sec square A, and on taking the LCM it comes out to be sec square A minus 1 divided by sec square A, and on solving it we get it to be root over sec square A minus 1 divided by sec A. As for the denominator, the root over and square get cancelled out. And for cos A we know that simply cos of A is equal to 1 by sec of A. And for tan of A, what we do is first of all we write tan of A is equal to root over tan square A, and we know from the trigonometric identities that 1 plus tan square A is equal to sec square A. So in place of tan square A we can write sec square A minus 1. And for cosec A we know that cosec of A is equal to 1 by sin A, and we put the value of sin A which we have obtained here. We replace the value of sin A with this, and we get the value of cosec A to be the reciprocal of this term, that is sec of A divided by root over sec square A minus 1. And for the last term, that is cot of A, we write cot of A is equal to 1 by tan of A, and then we replace the value of tan A from here, that is root over sec square A minus 1. So we get the value of cot A to be 1 by root over sec square A minus 1. So we have converted all the trigonometric ratios sine, cos, tan, cosec and cot in terms of only sec of A. Now the next problem is to evaluate by using the trigonometric identities. So the first problem is sine square 63 degree plus sine square 27 in the numerator and cos square 17 plus cos square 73 in the denominator. So our basic problem is here is to convert this both the numerator and denominator in terms of sine square A plus cos square A. So what we do is convert either one of these two terms in cos of A, and for the denominator we convert either of these two cos terms in terms of sine square. So for the numerator what we do is we convert this sine square 25 in terms of cos square. How we can do that? We know that sine of A is equal to cos of 90 minus A. So sine square A becomes our cos square 90 minus A. So sine square 27 becomes cos square 90 minus 27. And similarly cos square 17 degree comes out to be sine square 90 minus 17, and thus we get sine square 63 plus cos square 63 in the numerator and sine square 73 plus cos square 73 in the denominator, which comes out to be 1 using the formula sine square A plus cos square A is equal to 1. So we get the answer to be 1. Now the next problem is sine 25 into cos 65 plus cos 25 into sine 65. So what we do is convert this in terms of sine square A plus cos square A. In order to do that, we convert this cos in terms of sine and convert this sine in terms of cos. By using the same formula, cos of A is equal to sine of 90 minus A and sine of A is equal to cos of 90 minus A. So we get sine of 25 into sine of 25 plus cos of 25 into cos of 25. It comes out to be sine square 25 plus cos square 25. So we get the answer to be 1. Now the next problem is to choose the correct option and justify our answer. So the first one is 9 into sec square a minus 9 into tan square a. So we take 9 common from both the terms and we find sec square a minus tan square a in the bracket. And we know that 1 plus tan square a is equal to sec square a. If we transfer this to tan square a here, we get the value of 1 as sec square a minus tan square a. So we replace this value by 1 and we get the answer to be 9. So our answer is option number B, that is 9. Now let's move to the second part, that is 1 plus tan theta plus sec theta is into 1 plus cot theta plus minus cosec theta. So what we do is we solve this, we break this into simple terms. So it becomes, so we first multiply 1 with all the 3 terms, so we get 1 into this 1 plus cot theta and minus cosec theta, and then we multiply tan theta by all these 3 terms, so we get plus tan theta into cot theta and this minus tan theta into cosec theta, and then we multiply this sec theta by all these 3 terms, so we get plus sec theta plus sec theta into cot theta and then minus sec theta into cosec theta. And then we use 2 simple formulas, that is tan of theta is equal to sin theta divided by cos theta and cos of theta is equal to cos theta by sin theta. We also use sec theta is equal to 1 by cos theta and cosec theta is equal to 1 by sin theta. They are simple, I guess you remember that. So we convert that. Now in place of cot theta we write cos theta by sin theta, and cosec theta we write 1 by sin theta, plus tan theta, in place of tan theta we write sin theta by cos theta. And now we don't convert this in terms of sin and cos. What we do is we basically convert this cot in terms of tan, so it comes out to be 1 by tan theta, as these two get cancelled out. And then for this we write for tan theta sin theta by cos theta, and for cosec theta 1 by sin theta. And then for sec theta we write 1 by cos theta, and then again 1 by cos theta for this, into cot theta we write cos theta by sin theta, then minus for sec theta it is 1 by cos theta, and for cosec theta it is 1 by sin theta. Then we see that this sin theta can cancel out, this cos theta get cancelled out. Now here it is 1 by sin theta minus of 1 by sin theta, and here it is 1 of plus of 1 by sin theta. So this term and this term get cancelled out, and again we find that here it is minus of 1 by cos theta and it is 1 by plus of 1 by cos theta. So these 2 terms also get cancelled out. So what we remain is here 1 plus from here we get 1, and this term and this term. So we write those 3 terms like cos theta by sin theta plus sin theta by cos theta minus, here it is sin theta, the cos theta in the denominator and 1 in the numerator. Now we take the LCM of these 3 terms, which comes out to be sin theta into cos theta. So sin theta cancel out, so what remains is cos theta, so it becomes cos square theta here, and here it is sin square theta, and here it is 1, so it comes out to be 1 plus 1 plus Now cos square theta plus sin square theta comes out to be 1 minus 1 in the numerator and sin theta cos theta in the denominator. Now 1 minus 1, it is 0, and sin theta by cos theta. So it comes out to be 1 plus 1 is equal to 2, and this whole terms get equal to 0. So 2 plus 0 is equal to 2. So our answer comes out to be option number C, that is 2. Now the third part. Now here it is given that sec of a plus tan a into 1 minus sin of a. So what we do is convert the sec a is equal to 1 by cos a and tan a is sin a by cos a. We keep this sin a as it is, and then we take the LCM of these two terms to be cos of a, and we remain 1 plus sin of a in the numerator. Then we see that 1 plus sin a and 1 minus sin a comes out to be 1 minus sin square a, using the formula a plus b into a minus b. 1 square we get 1, and sin a whole square comes out to be sin square a. And also we know that sin square a plus cos square a is equal to 1. So cos square a is equal to 1 minus sin square a. So in place of 1 minus sin square a, we can write cos square a, and cos square a by cos a, it is cos of a. Like we can write x square by x, it comes out to be x. So cos square a by cos of a, it comes out to be cos of a. So our answer is option number D, that is cos of a. Now the last part, question number 4, 1 plus tan square a divided by 1 plus cot square a. So what we know that 1 plus tan square a is equal to sec square a, and 1 plus cot square a is equal to cosec square a from the trigonometric identities. And also we know that sec a is equal to 1 by cos of a, so sec square a comes out to be 1 by cos square a, and cosec a is equal to 1 by sin a, so cosec square a, it is 1 by sin square a. Now it is divide, if we turn into multiply, they get inverse, so it comes out to be sin square a by 1, and 1 get cancelled, and sin square a by cos square a, it comes out to be tan square a. So our answer is option number D, it is tan square a. Now let's move to the question number 5, that is to prove the given identities. The first one is to prove cosec theta minus cot theta whole square is equal to 1 minus cos theta divided by 1 plus cos theta. So what we do here is, first we take the left hand side, which is given to be cosec theta minus cot theta whole square. Then what we do is we convert the cosec theta and cot theta in terms of cos theta and sin theta. We take the LCM, which comes out, then we get 1 minus cos theta divided by sin theta, and the square remains as it is. Then we take 1 minus cos theta whole square, and sin theta whole square becomes sin square theta, and then we convert sin square theta into 1 minus cos square theta, and then we convert 1 minus cos theta whole square as 1 minus cos theta into 1 minus cos theta, and using a square minus b square, we get 1 minus cos square theta to be 1 plus cos theta into 1 minus cos theta, and then 1 minus cos theta get cancelled from the numerator and the denominator, and we remain with 1 minus cos theta divided by 1 plus cos theta, which is our right hand side. Now let's move to the next one. Here it is to be proved that cos a divided by 1 plus sin a plus 1 plus sin a divided by cos a is equal to 2 of sec of a. What we do is take the LCM in the first step, and then we get cos square a plus 1 plus sin a whole square in the numerator. We break it, and we find that the cos square a plus sin square a term here, so this gives us to be 1, and this 1 comes out as it is, and 2 of sin a. Then 1 plus 1 comes out to be 2, and 2 of sin a. From these two terms we take 2 common, and we remain with 1 plus sin of a, and there is 1 plus sin of a in the denominator as well, so these two get cancelled out, and we remain with 2 by cos of a, and 2 by cos of a we write it as 2 into 1 by cos of a, and 1 by cos of a it becomes sec of a, so ultimately it gives us 2 of sec of a, which is our right hand side. Hence we are done with this also. Now the third problem is to prove tan theta by 1 minus cot theta plus cot theta divided by 1 plus tan theta is equal to 1 plus sec theta into cosec theta. we take the left hand side and convert all the tan theta and cot theta in terms of sin theta and cos theta, as tan theta is equal to sin theta by cos theta and cot theta is equal to cos theta by sin theta. So we write this, and then we take the LCM in the denominator, both the terms, and we get sin theta minus cos theta by sin theta in the first term and cos theta minus sin theta by cos theta in the second term. We take the divide sign and convert it into multiply sign, so this get reversed. Similarly in this case also, so we get sin square theta divided by cos theta into sin theta minus cos theta here, and we find that here it is cos theta minus sin theta and here it is sin theta minus cos theta. So in order to convert this into sin theta minus cos theta, we take a minus sign common, and this plus turns out to be minus, and it becomes sin theta minus cos theta. Now we can take LCM of these two terms, which is sin theta into cos theta into sin theta minus cos theta, and there is no sin theta, so sin square theta into sin theta becomes sin cube theta, and there is no cos theta in this term, so we multiply this by cos theta to give cos cube theta. Now we know that a cube minus b cube is equal to a minus b into a square plus ab plus b square. So sin cube theta minus cos cube theta comes out to be sin theta minus cos theta into sin square theta plus sin theta cos theta plus cos square theta. Now this sin theta minus cos theta and this sin theta minus cos theta get cancelled out, and so we see that sin square theta and cos square theta, so we just simply put 1 in place of this, and we write sin theta into cos theta as it is, and we then separate the numerator 1 plus 1 and sin theta cos theta, so we get 1 by sin theta by cos theta plus sin theta cos theta divided by sin theta cos theta. This gives us 1, and we separate this as like 1 by sin theta into 1 by cos theta. So 1 by sin theta gives us cos sec theta, and 1 by cos theta gives us sec theta. So ultimately we remain with 1 plus sec theta into cos sec theta, which is our right hand side. Now the next problem is to show that 1 plus sec theta divided by sec theta is equal to sin square a divided by 1 minus cos a. So what we do here is we separately take the left hand side and right hand side and show that they are to be same. Firstly solve the left hand side, which is 1 plus sec a divided by sec a. In sec a we write it as 1 by cos a in the numerator and also in the denominator, and then we take the LCM and we get cos of a plus 1 divided by cos of a and 1 by cos of a. Then we reverse it by taking a multiply sign, then cos a get cancelled, and we remain with cos of a plus 1. And for the right hand side, what we do, we write in place of sin square a, we write it as 1 minus cos square a, and using the formula a square minus b square, we get 1 plus cos of a into 1 minus cos of a. This 1 minus cos of a and 1 minus cos of a get cancelled, and we remain with 1 plus cos of a. So we see that our left hand side is equal to our right hand side, and hence we are done with the proof. Now the question number 5. We are to show that cos of a minus sin of a plus 1 divided by cos of a plus sin of a minus 1 is equal to cos sec of a plus cot of a. But here the thing is, we need to use the identity cos x square a is equal to 1 minus cot square a. So what we do is, there is no cosec or cot in this term. So what we do, in order to bring cot and cosec, we divide both the numerator and denominator by sin of a. So we get cos a by sin a to be cot of a, sin a get cancelled and it comes minus 1, and 1 by sin a comes out to be cosec of a. Then similarly cos a by sin a tan cot of a, sin a comes out to be 1, and 1 by sin a comes out to be cosec of a. Then we take cot of a and cosec of a together, and in place of 1, as we know, cosec of a is equal to 1 plus cot square a. So we can write, if we take this cot square a in the left hand side, we get cosec square a minus cot square a is equal to 1. So in place of 1, we can write cosec square a minus cot square a. Then what we do is, we write a square minus b square formula here, and we write cosec A plus cot A into cosec A minus cot of A. Then we see that there is cot of A plus cosec of A here and cot plus cosec of A here. So we take common and we remain with 1 minus cosec A minus cot of A. There is a minus sign here. Just note it carefully. And then minus of cosec A and minus minus comes out to be plus. And we see that these two terms are exactly same. So they get cancelled out. 1 minus cosec A plus cot of A. And we remain with cot of A plus cosec of A, which is equal to cosec A plus cot A, and which is our right hand side. Hence we are done with the proof as well. Now the problem number 6, we have to prove that root over 1 plus sin A divided by 1 minus sin A is equal to sec of A plus tan of A. So what we do is multiply both the numerator and denominator with 1 plus sin of A. Then we get 1 plus sin of A whole square in the numerator and 1 minus sin square A in the denominator. Now this square and this root over get cancelled, so we get 1 plus sin in the numerator and there is a root over in the denominator. So it comes out to be 1 minus sin square A, it is cos square A, so we get root over cos square A, and again root over and square get cancelled, so we get cos A. So ultimately then we separate the numerator, we get 1 by cos of A plus sin A by cos of A. So 1 by cos A becomes sec A and sin A by cos A becomes tan A, which is equal to our right hand side, equal to RHS, and hence we are done with the proof. And next one is also very simple. We have to show that sin theta minus 2 of sin cube theta divided by 2 of cos cube theta minus cos theta is equal to tan theta. We take the left hand side and we take sin theta common from the numerator and cos theta common from the denominator. So we remain with 1 minus 2 of sin square theta in the numerator and 2 of cos square theta minus 1 in the denominator. Now in place of this sin square theta, we write 1 minus cos square theta. And then we break it. So we get 1 minus 2 plus 2 of cos square theta. And when we solve it, we get 2 of cos square theta minus 1. Which is what we have in the denominator. So they get cancelled out and we remain with sin theta by cos theta, which is equal to tan theta, and which is nothing but our right hand side. So we are done with this proof as well. Next one is also very simple. Question number 8. We take the left hand side, sin A plus 1 by sin A whole square plus cos A plus 1 by cos A whole square. We break it in with the help of formula A plus B whole square, A square plus 2AB plus B square. Here also A square plus 2AB plus B square. And we see that from here sin square A plus cos square A, it gives us 1, and here sin A by 1 by sin A get cancelled. We get with 2, this 2 comes here, and again cos A this cancel, and this 2 comes here, and 1 by sin square A, it is cos x square A, so it comes here, and 1 by cos square A, it comes here to be sec square A. And then we see that 1 plus 2 is 5, and also we know that cos x square theta is equal to 1 plus tan square theta, and sec square theta is equal to 1 plus cot square theta. So we get 5 plus 1 is equal to 7 plus tan square theta, and here it is cot square theta. So which is our right hand side, equal to our right hand side, and hence our proof. The next problem, it is also very simple, but here what we do, we take the left hand side and right hand side separately, and we see that they are both equal. So let's solve it. Left hand side is equal to, given to be cosec A minus sin A into sec of A minus cos of A. We convert cosec A in terms of sin A and sec A in terms of cos of A, and then we take the LCM and we get 1 minus sin square A into 1 minus cos square A in the numerator and sin of A into cos of A in the denominator, and then 1 minus sin square A is equal to cos square A, and 1 minus cos square A is equal to sin square A, and this sin A and sin square A get cancelled to be remain with sin A, and this cos square A cancel and gives us cos of A. So we remain with cos A into sin of A. Now for the right hand side, we have 1 by tan A plus cot A. We convert tan A and cot A in terms of sin theta and cos theta. So we get this we take the LCM sin theta into cos theta, and we have sin square A plus cos square A, and we take this sin A cos A top to the numerator, and we remain with sin A cos A divided by sin square A plus cos square A. Now this is equal to 1, so we remain with sin A into cos A, and here it is cos A sin A. So what we do, we write here also cos A into sin A. So what we basically have is right hand side is equal to right hand side, and hence we are done with the proof. I have left the question number 10 for your home exercise. You can try that on your own, and if you can't solve that, you can write in the comment section. I will make a separate video for question number 10. And with this I have completed your trigonometric chapter. I will also make one separate video for some more problems from different books and based on the previous year's question papers. But till now, if you have any problem related to any topic which is related to trigonometry, you can mail us in our given mail, or you can just write in our comment section. Thank you very much.